Have you ever pondered how fast the universe is expanding? Yes, you heard it right. The universe is expanding. It's not static or stationary. You might be wondering, where is it expanding into? Well, that's a question for another day. For now, let's focus on the idea of an expanding universe. Imagine you're standing at the center of a huge cosmic stage, and all around you, galaxies are moving away, like performers in an interstellar ballet, choreographed by the laws of physics. It's as if we're part of a cosmic loaf of bread that's baking in the oven of time, and every ingredient, every galaxy, every star is moving away from every other. Now, this doesn't mean that we are the center of the universe. It's just that, from our vantage point on Earth, it appears as if everything is moving away from us. In reality, all galaxies are moving away from each other, driven by the relentless expansion of space itself. But here's the crucial part. The universe isn't just expanding, it's expanding at an ever-increasing rate. Imagine you're trying to catch a bus, but the bus isn't just moving, it's accelerating. That's what's happening with the universe. So how do we know all this? Well, it's thanks to the work of countless astronomers and physicists who have dedicated their lives to studying the cosmos. They've used powerful telescopes to observe distant galaxies and sophisticated mathematical models to make sense of what they see. Through their efforts, they've been able to confirm that the universe is indeed expanding. But not only that, they've also been able to estimate the rate of this expansion, a value known as the Hubble Constant. This mind-boggling idea of an ever-expanding universe was first proposed by a man named Edwin Hubble. And it's his discoveries that we'll be delving into in the next scene, so stay tuned. Picture this, the year is 1929, and Edwin Hubble is peering through his telescope at Mount Wilson Observatory. Before we jump further into this cosmic journey, don't forget to hit the like button and subscribe to our channel for more intriguing mysteries of the universe. Now, back to the story. In this moment, Hubble was about to make a discovery that would forever change our understanding of the cosmos. As he gazed at the twinkling galaxies scattered across the inky blackness of space, he noticed something strange. These celestial bodies, these colossal collections of stars, gas and dust, appeared to be moving away from us. And not just that, but the further away they were, the faster they seemed to be moving. It was as if the universe was a giant balloon, and we were an ant on its surface. As the balloon inflated, every other point on the surface would seem to move away from us, and the further away the point, the faster it would recede. It was a mind-bending realization, one that flew in the face of the then popular belief that the universe was static and unchanging. But Hubble didn't stop there. He knew that observation was the first step, but understanding was the next. So he set to work, meticulously cataloguing the distances and velocities of numerous galaxies, painstakingly crunching the numbers. His tireless efforts led him to a stunning conclusion. The universe was expanding. Not only was this a revolutionary idea, but it also gave birth to a new constant in physics, the Hubble Constant. This constant, which describes the rate at which the universe is expanding, would become a key piece of the cosmological puzzle, helping us to understand everything from the age of the universe to the nature of dark matter. Hubble's discovery was groundbreaking. It forced us to rethink our place in the universe, to accept that we are part of a cosmic dance that is constantly in motion, constantly changing. It wasn't just a scientific breakthrough, but a philosophical one as well. It reminded us that the universe is far more vast, far more complex, and far more wonderful than we could have ever imagined. Hubble's discovery was groundbreaking. It changed our understanding of the universe forever. So, what does Hubble's discovery mean for us? Well, to answer that question, we need to dive into the realm of the Hubble Constant. The Hubble Constant is a value that measures the rate at which the universe is expanding. It's a bit like the speedometer of the cosmos. Let's break it down further. The Hubble Constant is named after Edwin Hubble, the same chap we talked about in the last scene. The constant part refers to the fact that this number doesn't change, no matter where you are in the universe. So, how does the Hubble Constant help us measure the universe's expansion? Imagine you're on a road trip and you're tracking your speed. If you know how fast you're going and how long you've been driving, you can calculate how far you've traveled. The Hubble constant works in a similar way. By knowing how fast galaxies are moving away from us and how far away they are, we can calculate the size of the universe and estimate its age. Now, what's so special about this constant? Well, the Hubble constant is crucial for understanding the universe's past, present, and future. It's like a cosmic clock, telling us how long the universe has been expanding. And by knowing the rate of expansion, we can estimate the age of the universe, which turns out to be around 14 billion years old. Pretty amazing, right? The Hubble constant also gives us a sense of the universe's size. By measuring how fast galaxies are moving away from us, we can estimate how big the universe is. And it's big, really big. We're talking about trillions upon trillions of miles. So, there you have it. The Hubble constant is like a cosmic speedometer, a galactic clock, and a celestial tape measure all rolled into one. It gives us a glimpse into the universe's past, a snapshot of its present, and a peek into its future. But as with all things in science, the Hubble constant is not without its controversies. Why is there a debate about a constant? Shouldn't it be, well, constant? Well, you'd think so, but the universe is full of surprises. And one of its most confounding has to do with the Hubble constant, the value we use to measure the rate of the universe's expansion. You see, there's a fascinating controversy brewing in the world of astrophysics. Different methods of measuring the Hubble constant have led to slightly different results, and this has sparked a lively debate among scientists. On one side, we have measurements taken from the cosmic microwave background, the afterglow of the Big Bang. These measurements suggest a Hubble constant of around 67 kilometers per second per megaparsec. On the other side, we have measurements taken from Type Ia supernovae, exploding stars. These readings suggest a Hubble constant of around 73 kilometers per second per megaparsec. The difference might seem small, but in the grand scheme of the universe, it's a pretty big deal. If the higher value is correct, it means the universe is expanding faster than we thought. And this could have profound implications for our understanding of the universe's age, size, and ultimate fate. But here's the really exciting part. This controversy isn't a sign of failure. Far from it. It's a testament to the progress of science. It's a sign that our tools and methods are becoming so precise, they're revealing discrepancies we couldn't see before. What's more, this debate is inspiring new lines of inquiry and innovative solutions. Scientists are exploring new ways of measuring the constant and seeking new cosmological models that might reconcile the conflicting values. So in a way, this controversy is a sign of a thriving, vibrant scientific community. It reminds us that science is a journey, not a destination. It's about asking questions, challenging assumptions, and being willing to revise our understanding in light of new evidence. This controversy, far from being a hindrance, actually pushes science forward. So, what does the expansion of the universe mean for its future? Well, the truth is, we're not entirely sure. There are several theories, each as exhilarating and mind-boggling as the other. Let's take a look at some of them. First up is the concept of the Big Rip. This theory suggests that if the universe continues to expand at an increasing rate, the gravitational forces holding galaxies, stars, and even atoms together could be overcome. The result? Everything would be torn apart, right down to the atomic level. Quite a dramatic end, don't you think? Next, we have the Big Freeze scenario. This theory posits that if the expansion slows down but never quite stops, the universe could stretch out indefinitely. Stars would burn out, galaxies would drift apart, and eventually all would be dark, cold, and lifeless. Not exactly a cheerful prospect, but it's a possibility we can't ignore. Then there's the Big Crunch. If the universe's expansion rate slows down enough, and even reverses, we could see everything converging back into a single point, much like the singularity from which the Big Bang originated. It's like hitting the cosmic rewind button, leading to a possible rebound in another Big Bang. It's important to remember that these are just theories, educated guesses based on our current understanding of the universe. As our knowledge expands, just like the universe itself, these theories may change or evolve. We may discover new possibilities we can't even begin to imagine now. In the grand scheme of things, our existence is but a fleeting moment in the universe's timeline. Yet, it's incredible to think about how we, tiny creatures on a small planet, are able to ponder these vast cosmic mysteries. Whatever the future holds, one thing is certain. The universe is a fascinating place, ever-changing and full of mysteries waiting to be unraveled.